What I want to do is I want to work on another piece of the puzzle, trying to catch you back up, give you a little bit of extra work to get you to understand some of the concepts that you're going to be using in pre-calculus, in Algebra 2. So everybody gets to see these videos and everybody gets this little bit of knowledge. We're going to talk about the radical today. The radical is a square root symbol, all right? It can be a cube root, other types of roots, but right now what we really want to talk about are square roots, and that's the basic idea. The first thing we do is we look for a number inside that symbol that is a perfect square. And we know for a fact that 9 is 3 times 3, right? So we know that 9 is 3 squared. This symbol here says undo that square, all right? And then we say that the square root of 9 is 3. Sounds good? Okay, that's the basic concept. The next thing we need to talk about is what if there's a negative in front of that square root symbol? Well, the good news is we don't have to do anything with it. We just bring it down and it'll be part of our simplification. All right? So the negative out front means there's a negative right here. And we know that 5 times 5 is 25. We know that that's a perfect square. And that square root symbol, or that radical, undoes that square. And so we say the square root of 25 is 5. The negative has been brought down, so our final simplification is negative 5. The interesting part about having variables inside a square root is we look for sets of 2, right? Why sets of 2? Or we divide the exponent by 2. What if we have a squared? Well, if we put a radical around a squared, we would have a, right? We would undo the square, which means we just have an a there. And so we think about it as dividing by 2, because 2 divided by 2 is just 1a, right? And so let's look at this. If we take this a to the 6th, and we divide by 2, because it's an even number, it's nice and simple. We take this even number, we divide by 2, and we have a to the 3rd. Does that make sense? Well, sure, because a squared times a squared times a squared is a to the 6th. Okay, well, we'll undo the square here, we'll undo the square here, and we'll undo the square here, and we have a times a as our answer, which is the same thing as a cubed, or a to the 3rd. Okay, so we've got this all set. Now let's move on to something that's a little bit more difficult. And this is the part that really starts to trip people up. Sometimes we don't see a perfect square there. When we look at 75, we're not really sure. What is 75? Well, 75, is there a perfect square in there? Is there a number that's a perfect square in there? And you say, I don't know. Well, this happens to be, we think pretty well in 25, so we're okay with that. So 25 times 3 gives me 75. Now, I can take the square root of 25. I can. And I'm going to rewrite this in a minute, but I'm going to work on the exponents as well, or the variables as well. And this is it. This is the whole thing broken down. I want you to think about each individual piece as being underneath their own radical. This is the same thing as what you see above, okay? This is the exact same as this, is the exact same as this. If we did the multiplication, we would end up with this. And this is the whole thing broken down. Now, there are a couple of pieces where we actually can take the square root, right? There's a 25, so I can take the square root of 25 and I have 5. Can I take the square root of 3? No, I can't. It's not a perfect square, all right? So I'm going to move on. Can I take the square root of x squared? Of course I can, and I have an x. And I'm going to put multiplication symbols in the middle and do that. Can I take the square root of x? No, it's just one of them. If it were x squared, we could take the square root of it, but just x, we can't take the square root. So, now that I've done this part, I can take anything that's outside that doesn't have a radical around it and multiply it together, which means 5 times x on the outside, and let's see what's left over inside a radical, or under a square root symbol. That's a 3 and an x. And while it looks a little bit challenging, that's really all there is to it. All right, I'm going to give you some problems to go along with this, and this will be part of what you turn in on Friday on top of your regular classwork. Thanks for watching, and I know you can handle it.